G'day, and welcome to this Next Level CAD video. In today's video, we're going to be taking a quick look at top-down modeling and the benefits when it comes to creating models and using repeatable designs. So that could be something that you make frequently, but the overall sizes change, but the design methodology and the general fabrication processes all stay the same. It's basically just different size parts to make up your different levels of assembly. So today I'm using the example of just a window. Now, I've never designed a window a day in my life, so I don't know if all these things are technically correct or if sizes are correct, but it demonstrates the process perfectly, and it's something that we should all be intimately familiar with by now. So just a standard sliding glass window with an outer frame and fixed pane and a sliding pane. And I'm going to use this as an example so you can just see how quick and easy it is to change up a model. Now, this is our overall assembly, and here are our three sub-assemblies in here. In each one of these sub-assemblies, we have 4 parts for our external frame, and then 5 parts, including our piece of glass for our internal frames. Piece of glass you can't really see at the moment. So all of that is in there, and by simply changing one sketch or a couple of dimensions in a sketch, we can change our entire size and all of our parts within this assembly. So the difference between top-down modeling and what's typically referred to as bottom-up modeling is that bottom-up modeling is typically the first way that you will learn to do a 3D model in something like Inventor or SolidWorks or any other parametric modeling program, where you draw a sketch, create some geometry, make your part look the way that it needs to look, and that's fine if you're just modeling an individual part. But when you need to add that part to an assembly, that becomes exponentially more difficult to make modifications to those parts and those assemblies, because where 2 parts interact with each other, e.g. where you may have a set of holes or something, if your parts are modeled bottom up individually, it means that when you make a movement of a hole, for example, you need to move something over 10 or 15 mil, you have to go through and make that same change for every part, and that can potentially then throw out things like constraints in your upper level assemblies. So it makes things far more difficult to modify. With top-down modeling methods, you don't have to have that same workflow. Things are all adaptive to each other, and changing things is a heck of a lot smoother. So, like I say, if you're doing something that's the same but a slightly different size, this is really the method that you want to go for. And it's one of those things that once you learn how to do this method, you never look back. You always use top-down modeling for anything where there's 2 or more parts that are interacting with each other. So as you can see here, I've only got these 5 sketches cover all of the parts, all of the features that you see in these parts, all the geometry that's there. So you can see we've got our frames and our piece of glass in there. The locations are all governed off these sketches. So if I just do a quick section view through here, you can see we've got a tolerance gap there for heat expansion and for gaskets to go in, and everything is centered nicely. And it's all of this information is driven just off these sketches that we've got in here. So I've allowed for the fact that, say, a builder may ring up and say, I need a window to go in a hole that's 1200 by 600. So that's our overall size is 1200 mil by 600 mil. And then the frame window size will be 10 mil less of that because we've got a 5mm fabrication tolerance / building tolerance / dodgy measurement tolerance in there. And this means that our overall frame should actually come out that 1190 by 590. So just to show that that's all working, we'll go back to our drawing here. So our drawing is 1190 by 590. Right, so we've got our model definitely linked to all our drawings. You can see I've shown some detail that you may typically see on a window drawing. Again, don't know if this is accurate or not, but it'll show what I need it to show for this demonstration. You can see our inner frame drawing. and our cut list here. So these dimensions are also linked to our models, so that as we update, should just automatically update our drawings and all of our cut sizes. So you can just take note that our window is currently 608 by 560, which is our our glass size once all of our tolerances and our gaps and things are taken into account. That's the piece of glass that we should need to cut for these windows. And the same thing is here because they're equally spaced. So you can imagine if you're making windows and that this was your design, this would all be basically a drawing that you need to do to get these things built. So if we go back to our driving sketch, and our builder's rung through now and says that he wants a window to fit an odd sized gap, let's say it's 1 meter by 750. We can go back now, finish that sketch, go back to our model, remove our section view and hit the update button. There we go. Our window is automatically updated. So you can see all the parts on the side there updated. And if we go back to our drawings automatically update. Now there's some tricks to making sure that these things don't fall apart like this one over here did. But you'll see that now all of our cut sizes are updated on our drawings. Same is true for the second frame, and the outer frame is now correct with tolerances in. And if we go back to our first drawing has stayed the same, but our dimensions have updated. Now you may have to go through on each one of these and just tweak things around a little bit and make sure that texts aren't overlapping or that views haven't wandered off or whatever it is. But you can tell that this would be a heck of a lot faster to now copy this design and make your next window. So this could take something that potentially takes hours to draw down to quite literally minutes if you've done your model from top down versus bottom up modeling. If this is a method that intrigues you or you'd like to learn a little bit more about it, feel free to get in touch with the details that are on the screen. Don't forget to hit like and subscribe to let us know that you're out there and you're watching. And thanks for watching. Catch you in the next one.